Okay, today I'm going to talk to you about momentum. Now, it's a bit of an abstract concept. Every moving object has a quantity of motion, and that quantity of motion is called momentum. It's essentially how much oomph an object has. If an object has more momentum, it's more difficult to get it to stop. So, momentum relies on two things, and I think it's kind of easier when we start to see examples. It relies on mass, and it also relies on velocity, so the speed at which something is travelling. So, again, I think it's easiest if we just have a look at an example. So let's imagine I have a man right here. This man, he has a mass of 75 kilograms. Now, he might be running at a speed, or kind of jogging at a speed of 5 meters per second. So, to calculate his momentum is nice and easy. All I need to do is his mass, so 75, multiplied by his velocity, which is 5. So even if you think you could do this in your head, remember we always double check using a calculator. So 75 times 5 is 375. Now the units for momentum, a lot of people get wrong. Because we're just multiplying them together, it's just kilogram meters per second. There's no stroke sign here. Loads of people like to do per here. There's no per here because we're just multiplying them together. Now, let's imagine that instead of having a 70 kilogram man, I apologise in advance for my terrible drawings of a van. Right, there it is. So let's say this van is also travelling at just 5 meters per second. Okay, but this time this van is 1,000, let's say it's 1,500 kilograms. Okay, so even though they're travelling at the same velocity, this one is going to have a bigger momentum because instead this is 1,500 times 5. So therefore, let's have a look at this. 1,500 times 5. The momentum of this is going to be much bigger. It's 7,500 kilogram meters per second rather than this one. So we can see it depends upon the mass. Right, let's have another look at another couple of quick examples. So let's say we've got another person here, but this person isn't moving at this point. They're completely stationary. So let's say that they have the exact same mass as this other person here. They are also 75 kilograms, okay? So this person, right now, their momentum is 75, because that's their mass, multiplied by their velocity. Because they're not moving, their velocity is 0. So we can see that stationary objects have no momentum. Momentum is all about the quantity of motion of a moving body. Right, now let's imagine this person here is also running, but this is one of the fastest people on the planet. They can run at 10 meters per second, okay? So, even though they're the same mass, the momentum is going to be different because momentum relies on mass and velocity. So the bigger the mass, the higher the momentum. The bigger the velocity, the higher the momentum. So this time, this one is 750 kilogram meters per second. So we can see, even though they're the same mass, this person has a greater momentum because they have a greater velocity. Okay, so that's the basics of momentum. Let's have a look at something a little more complex. Let's imagine, again, apologies for my awful vans, I'm not an artist. Let's imagine we have these two vans. Let's say this van is 2,800 kilograms, and let's say this van here is 2,600 kilograms. Now, what has happened is this van has lost control, and it's going to slam into the back of the other van at a speed of 10 meters per second. So what's going to happen is it's not going to just stop dead. Both of the vans are going to move, keep moving, they're going to lock in and move together like this. So what I'm trying to find is what is going to be the velocity once the van bumps into the other van. So this works on the idea that momentum is conserved. The amount of the momentum that the vans will have together afterwards will be the same as the amount of momentum that this van had initially. So the first thing that I need to do is find the amount of momentum that this van had before the collision. So to find momentum, I do mass times velocity. So I'm going to do 2,800 rather, multiplied by 10, which is going to give my momentum of 28,000 28,000 kilogram meters per second, okay? So that's my amount of momentum before the impact, before the collision. So what I need to do now is find the velocity. How fast, what's the velocity going to be of these two vans now they've collided? So I need to find the new mass, which is going to be the sum of these two, because now they're kind of locked together. We need to add these together. So to find my new mass, it's going to be 2,800 plus 2,600, which equals 5,400 kilograms. Okay? So that is the combined mass of these two now they've collided. Okay? So, because of conservation of momentum, the momentum is going to be the same after the collision as before the collision. To find the velocity, I'm going to do momentum divided by mass. So my momentum is going to be exactly the same as this van had initially. So to find my velocity, I'm going to do momentum divided by mass. So velocity equals momentum divided by mass. And it's going to be the combined mass of these two. Now they're locked together. So my velocity is going to equal 28,000 divided by 5,400. Now I definitely need my calculator for this one. So to quickly do this one, the velocity is going to be 28,000 divided by 5,400, and to do it to two decimal places, it's 5.19 meters per second. Now that's what we'd expect. We'd expect it to be slower because it started off at 10 meters per second. As they collide, they're going to carry on moving, but that is going to be the velocity of their new movement. And that, guys, is basically momentum. Thank you.